Hello, Paul Hamler here. Welcome back. I'm going to try to do a short little video here of making a half-scale reproduction Lincoln head and a Raven head axe. We're going to call this episode Welcome to 3F Manufacturing. That's 3F in fakes, frauds, and forgeries. Today we're going to make a forgery reproduction of a half-scale double-sided Raven or Lincoln axe. And what we're going to do is we started out with a relatively inexpensive double-sided axe. I've also got a single one we'll be doing. And what we're going to do is prep them, grind off the stamp logo that was stamped in these relatively inexpensive axes. This is more or less a market research project to quickly turn out a sample to see what the response to the axe and tool collectors will be on this product. I have no idea, but I've had several axe collectors bugging me to do this for years, so we're going to give it a quick try. Here are the two logos that we'll be putting burning chemical etching onto the axe heads after we get them sanded and prepped. The castings on these axes are pretty crude, so we're having to smooth them up on the belt sander and the sanding disc today. This will be what we're shooting for in a half scale axe. I've already got the etching plates. This was the original artwork. I've got the silk screen templates done from this artwork, and they're scaled down. Let's see if we get a close-up. These were just test burnings to test out, just a test burn on a piece of scrap steel. Anyway, we'll get a better shot of it once we get it etched onto the final product. Okay, let's do some sanding here. Okay, we got it roughed out a little bit on the belt sander. What we're going to do now is use this expanding rubber wheel to bring it down a little bit closer to finish. And I don't know if I'll be able to do it in this video or not, but these expanding rubber wheels are used in the lapidary industry. If you've never used one, they're absolutely fabulous as far as feel and touch. What I've got is a belt here that I turned inside out just to show you where I have made. The belts are rather expensive, but I'm going to show you a process either in this video or a following video of how to make these belts, not only for this machine here, but it's also a good technique for splicing belts for a flat belted type machine like a South Bend lathe or a drill press with a flat pulley on it. Anyways, we'll describe this process hopefully at the end of the video or in an upcoming video. But what I'm going to do right now is spend a little time grinding or sanding with this expanding rubber wheel. I think it's a 50 grit on there now. I'll drop it down to finer grits as we get closer in. time to switch again. Okay, getting a little closer. We got any body men out there, I'm sure they'll recognize that last process. So I'm gonna go off camera now and finish sanding this thing up and getting it detailed. And we'll get back over to the bench when we're ready to burn and etch the logo into the steel head. Be back in a little bit. Okay, we pretty much finished up the power sanding on the axe head here to get all the dimples out of it and get it cleaned up. Just gonna do a small little touch up here with my little sanding block. The little box here has got an adjusting screw that goes up inside of it, and you can tighten it, which pushes the front section out and puts tension on your belt. Got a few designs in this block here. I'm currently having a bunch of them manufactured, so hopefully they'll be available for sale within the next few weeks. We're going to be selling them out on Steve Lindsay's website, so keep an eye out there and see when they're available. Just got back from the etching bench, and we etched the Lincoln logo on this single edge hatchet, and I'm finding it very difficult to take a picture of this thing because of the glare. So I moved it over here to photograph it, and you can see the logo that we just etched in there. Turned out pretty decent. What I'm going to do now is go film the etching of the Black Raven, and you can see the process that I went through to achieve the etching on this single edge axe. Before we etch the double-edged axe, just give you a quick overview of what we're going to go through. Again, this was the artwork on the Lincoln axe, and from it we produced a silk screen, real fine silk screen. The mesh on this stuff is terribly tight. And what I did, and what we're getting ready to do, is you tape this down over your clean piece of metal, and with the electrochemical etcher, you've got a AC and a DC supply inside of it. This is a unit I'll be using. It's called electrochemical producer model 100. And most all of these chemical etchers have two settings. Electrochemical etchers have two settings. The solution that puts on your pad is like a salt solution. It acts as a conductor for the electrode, and you put the rectifier on one side of your metal, and then you blot it down on top of your silk screen, and it burns or etches the metal away in the metal. Now there's two functions on most of these etchers, AC and DC mode. AC is more for marking. It doesn't go in and penetrate as deep it's more of a marking process. When you use DC, the current gets transferred through the solution in the pad and burns away or etches the metal. I guess one could kind of look at it as a primitive EDM, plunge EDM machine. Now, Murphy's Law, I've only used this machine a couple of times, but when I turned it on to do the video, the DC section of the rectifier is broke. I don't know whether I got a bad rectifier or what. I am getting AC out, so unfortunately what we will do is just mark what we refer to as marking, and it will transfer the pattern onto the metal. Not quite as deep or as permanent as when you do a DC etching. And rather than stopping in the middle of the video and trying to fix the thing, I said, well, I'll just do an AC etch versus a DC burn. So what we got here is the pad. It's a carbon pad, and it's got a felt pad over it that's been saturated in the chemical. It's the salt solution, and again, it's a conductive to transfer from that to the metal. On the axe, what we've done is attached with a piece of tape. We've attached the stencil, the silk screen. Let me get a focus on this. So I've got it taped in place. The metal has been cleaned, and what I'm going to do is lay it back down flat and turn the rectifier on and hold the pad over the stencil, and the current will flow through that stencil and darken and mark the light colored areas on the stencil. So let's see if we can make it work here with okay. It looks like we got a good mark. At this point in the process, you remove the stencil. You always want to clean it. There's a cleaning solution that you can clean the solution with and get any salt out of there or any contaminants. What I do is I just normally flush it with the cleaning solution. I'll lay it down on a paper towel and blot it. And after it's been blotted, I'll just set it aside, leave it flat, let it dry. So that stencil will probably be good for, I don't know, 300-400 impressions. Now, you want to clean your etching or your marking with the cleaning solution, and you know, this is it's permanently marked in there and burned in there. Not the best one I've done, but that's par for the course when you're shooting a video. Put a mechanical pencil in there for scale. I'll try to zoom in and get a close-up. I can't handle the glare. but I think that's good enough. You get the idea. We started with a $16 Indonesian-made hatchet. Did a little grinding on it, cleaned it up, and wanted to photo etch them, but I guess the proper term for this particular operation here would be photo marking. But the it's a pretty permanent etching or marking, very similar to what they put on tool bits, drill bits, and end mills and things like that to mark the size of them. So it's a lot more permanent than you know, magic marker. So with that, we're going to kind of shut it down and might do a closing here in a minute. Okay, welcome back. Hope it didn't bore you to death with all the sparks and the sandings, but if you can read this, it says now for the good stuff. What I'm going to do is share with you a few tips in the sanding arena in my sanding blocks that I referred to earlier, and push a few products here that I feel like a lot of guys will know about them, some of them won't, but it's something I use and I believe in, and don't get any feedback from the manufacturers. It's just passing on this information that I think you might be able to use in your endeavors. So with that, what I'm going to do is show you a close-up view of this rubber wheel, expanding rubber wheel we was using on sanding out the last stages of the axe. Okay, a little close-up of this wheel. Maybe you can see from the depression here. It's not a hard wheel. It's I don't know, I'd say shore hardness of 80 or something like that. But it's got slots in it, and the manufacturer says that you can reverse this thing in one way with the diagonal slots going one way. It's a little firmer than in the other way. Quite honestly, I can't tell that much difference. But the thing I want to stress about this is these guys, when you're using a round curvature sanding surface like I did when I started out the axe on the belt sander, it's bouncy and it's rough. This wheel here, it's made and used in the lapidary industry. You can, two sources that I'm aware of to buy these things. One is from Rio Grande, and they're referred to as lapidary wheels, and I understand the one that I have here is about let's see, it's a 1.5 inch, 1.25 inch width, and they're about 6 inches in diameter. I understand they've got a wider version out now. The other source that I've been able to find these expanding rubber wheels is from an automotive restoration company, Eastwood, and just Google them, and they handle these as well. The belts, if you purchase these belts, they're somewhat expensive. So what I struggled with for a couple of years was a method to make my own belts out of shop roll. And here's like the inside of one that I spliced with shop roll, the red shop roll. Here is a commercially spliced belt for this rubber wheel, made by 3M. And a lot of you guys that use a 6x48 and other continuous sanding belts will recognize this striped fiberglass reinforcement tape. Checked into the process involved in this. It's a proprietary process, requires some very expensive equipment, and so over the years I've tried duct tape, I've tried Gorilla tape, siding tape, but nothing until I stumbled on this process works as well as what I'm getting ready to describe to you. What you see here is a piece of Mylar sandpaper. And there's something about the mylar, the super glue, and the cloth backing on most of these shop roll type belts. It's almost like the contact of the mylar and the super glue it acts as a accelerant. Hard to describe, but I will assure you, if you follow the steps I'm fixing to go through on splicing these belts, this joint that you can make relatively inexpensive will be every bit, if not stronger, than what 3M does. So I encourage you to try it. The other thing about these sanding belts, you can buy them in a material that's called Trizac. It's a 3M product. For those not familiar with it, we'll try to get a close-up of it here in a minute. These are a couple of samples of Trizac belts. The knife makers use them quite a bit. 2" by 52, they go on like Baldor knife grinders and etc. But picked some up at a salvage store, and I had never been able to splice a Trizac belt with all the other methods I had tried. But it's very successful with the method I'm getting ready to show you here. Trizac, they're hard to locate. You can buy them off of Amazon. Unfortunately, you have to buy a bulk quantity, so you might want to get a couple of your buddies to go in with you and buy, a pack of them. But the Trizac belts, the way I understand the way these guys are manufactured, the belt is flooded and loaded with an epoxy, and then they put little microscopic abrasive balls into the epoxy, and then they mill it. And if you look at it up close, I'm sure if we can get a shot here, it looks like almost like a mesh of screen wire or something. But what happens as the belt wears and wears away, more of these the way they're milled, when they're crisp and fresh belts, these look like little pyramids. But as the belt wears and you get use on it, these pyramids get flattened out, and you are constantly exposing new, fresh, microscopic abrasive spears that's embedded in this material. The two things about it: one is because the size of these microscopic spears are all the same, you never have a wild grit or a wild hair, particularly if you're finishing ivory or some kind of plastic. They're very uniform, and you won't have that wild grit that takes place when you using regular, aluminum oxide or other conventional type papers. The other thing, they're a little more expensive, say on a 6x48. The 6x48s are a little more expensive than the, say, aluminum oxide. Not that much, $3, $4 a belt. However, I will assure you that this Trizac belt versus aluminum oxide will outlast 4 or 5 aluminum oxide belts. They're well worth the investment. Okay, don't want to draw this out to a long scenario here, but I'm going to run through real quick how I splice these belts. The way I ran across this process, as I mentioned in the earlier video, I designed these little sanding blocks. There's 3 different styles. I don't have all of them here, but I'm currently having them manufactured, and they should be available here, hopefully, not too long. The first style I came up with here uses just a continuous or an open belt, and it's held captive in the back. What's unique about the design that I came up with on initially, this guy here, is once you put your paper in the ball back in the back here and tighten it up, in order to tighten it up, you run an Allen wrench in here and tighten it, and it pushes that nose forward. That gives you an extremely tight fitting sanding belt. Stage 2 of the process was I went in and made the disadvantage of this guy. It has advantages and disadvantages. The disadvantage is if you're working out on the nose, you wear your paper here, and unless you've got a use for the rest of the paper, there's a lot of waste involved. So, second design, we came up with this guy here. Put this Allen wrench in through the side. Same process to tighten and extend the nose forward. The difference is this uses a continuous belt. Now I have a model, I don't have it with me, but I have a model of this style here that also has the tapered nose on the front. But same concept, once you put your paper on, you tighten the Allen wrench, it shoves the nose forward and gives you a tighter belt. The problem I ran into is you can get any commercial belt manufacturer will make you up a series of these belts, and they're not that expensive, but if you don't want to make them yourself, you can get them made to fit the sanding blocks. The advantage of this, if you got the nose front on it and it starts wearing up here, you back the tension off and rotate the belt. I know all of you seen the hobby model versions of this. It's made out of plastic. This guy here is a little heavier. You got more mass, more rigidity, and you got the benefits of being able to adjust and tension your paper. The only sanding block I've ever used, for years I've tried to use the Trizac belt material on a sanding block, and for whatever reason you can't just two-side tape it or super glue it to a flat stick or a ruler and get it to work that efficiently. So this was the last design here. What we did is put a fairly strong spring inside the unit. You compress it and put a stop pin in there. Now you can slide your belt off. Again, it's a continuous belt, so you have to make your custom belts for these two styles here. So enough said about the sanding blocks. Well, let me show you how I splice these guys. We'll use this guy as an example. I don't know which. Okay. It's not rocket science. The Mylar belt that we're going to, or the Mylar strip that we're going to use to bond the two pieces of the shop roll together. A lot of you guys will recognize this. It's a 3M, they called it micron. It comes in different grits. But this is a Mylar paper. You can't tear it, you have to cut it. Now, there's a lot of other sources and supplies of Mylar, but I think one thing is key is, as I said earlier, the reaction of the super glue, the Mylar, and the cloth belt. So, what I'm going to do is just show you real quick how I do this. A word and a testimonial before I start on super glue. All super glues are not created equal. And in the 40 years of fooling around with the stuff that I've done here in the shop, I have never found a super glue that works any better than this. You can buy it at Home Depot. It's great stuff. If you got your preference and your brand, you're happy with it, and it works on this, you know, that's fine. But thought I'd pass that on to you. So what you do is, if you like on these the belts for the expanding sander, what I did is I cut one that was wore out. I cut it at the seam where it was joined, and then I manufactured a stick that had the taper on each end the stick being the exact length that I wanted that belt to be. So you could do the same thing on these blocks. You can make you a stick that fits the perimeter that you need for your particular sanding block, or you can wrap this guy over, cut one angle first, then mark it with a pencil, and with scissors cut that for your required length. Of course, we're doing this on a video, doing it fast, so you know it's not going to fit. I mean, that's the way it's going to work. Anyway, then you cut you off a piece of the mylar. Now, the important thing about the mylar is you're working with and using the back part of the paper, not the grit or the abrasive part. So, what I do, don't flood it. Just put your light spread of super glue on the mylar. Lay it down here, and finger pressure. Just squeeze the surplus super glue out of there. And if you got good fresh super glue, didn't bring a paper towel, you trim this guy off. Now, while I'm doing this, I'll mention again, I have actually made a flat round belt for a Delta drill press that the belt just disintegrated one day. And by using some of the longer strips, like they use in the 2x52 belt sanders, I sized it to width and I actually spliced it, and it's been running for 6 months and it's performing flawlessly. Also, just to see if it was possible, it was more or less a test for me to understand how strong that joint was. So what I did one day is I took a long piece and I sized it, I sized it and I put it up inside over the motor pulley and over the headstock pulley on my South Bend lathe, and then I glued it up and put it back in there, and it worked perfect. The weight of the motor, when you engage and put tension on the belt, it held up fine. So might be a quick emergency fix if you ever break a belt and you need one. Okay, we'll trim this off, do the same thing, put a little super glue on the mylar. Again, we're putting it on the back of the mylar, put a little on the cloth belt, and then come in here, line it up, put your finger down there, hold it down. If you're safety oriented, you might want to use a paper towel, that way you don't glue your fingers together, but hey, a real man doesn't use orange gloves. Okay, let that set for just a minute, and I think that's about it. Now, get one of these sanding blocks, you make you one or whatever. You can put extremely fine paper, or you can use this stuff here is good. I use a lot of this on the blocks. Here's a block band of 40 micron. But if you got real fine paper, you can lay it down on a piece of tape, duct tape, whatever, any type of tape to reinforce the thin paper, because this guy, but you notice the fit, it's not tight, but it's snug. Then you go in with the Allen wrench and watch the crack of the front nose piece expand as I tighten this set screw. Now, that belt is on there snug. It's flat. When it wears on the ends, I can loosen the set screw and rotate the belt. You want to be careful not to try to rotate the belt across the mylar joint. The mylar joint is not that flexible, so you kind of have to sneak it around and then keep the joint up on the ends. Anyhow, that's pretty much all I can share with you on that. I hope it's of a benefit to you, and I hope you enjoyed the axe video. Hope it wasn't too much sanding in there, but we'll finish these handles up here in a day or two and get these guys more presentable. But with that, we're going to call it a wrap, and you guys have a nice day, and we'll catch you next time.